In this unit, we're going to look at electrochemistry, and electrochemistry is one of the topics that I get unreasonably excited about. And you're probably saying now, Dr. Lutz, you get unreasonably excited about too many things in second semester. I know, but electrochemistry is really cool. Um, Electrochemistry is the study of the interchange of chemical and electrical energy. So, how do we use chemical reactions to get electrical energy? This is one of the ways of using that free energy that we claimed to have when we calculated Gibbs free energy. And we'll do a bit of a unit review and then go into what an electrochemistry setup looks like. So amps, which has a capital A for its unit, this is the rate of electron flow through a wire. Just right, hint, hint. This is how we're going to get electricity is let electrons flow through a wire. And 1 amp is equal to 1 coulomb per second. So it is per second, right? It's a rate. And then coulombs, that's the charge. So 1 amp is 6.242 times 10 to the 18th electrons per second, based on the charge on an electron and in coulombs and the fact that 1 amp is 1 coulomb per second. We will also run into volts, which has a capital V. This is a potential difference, but they just leave out the word energy usually. It's a potential energy difference. So when you have two parts of reaction and you are putting them in contact with each other, the difference in potential energy will tell you stuff about the reaction, just like the potential energy of an object tells you about the potential of that object. So 1 volt is equal to 1 joule per coulomb. We will need this conversion constantly. The potential difference, or this value in volts, it's also called EMF, which I think you will see EMF show up a lot when people are talking about like the dangers of electronics. This is the EMF stands for electromotive force. Okay, types of electrochemical cells. A galvanic cell is a cell in which a spontaneous reaction occurs. So galvanic will be code for spontaneous or thermodynamically favored when we are putting cells together. And an electrolytic cell is a non-spontaneous reaction. So you might say, what's the point? It's not going to be thermodynamically favored when I put it together. True, but there's some really important reactions that are non-spontaneous or not thermodynamically favored when we put them together. But I mean, the galvanic cell will make electricity. Like, we can just apply a voltage and push this reaction and make it go. So all electrochemical cells will have the same basic setup. The only difference between the two is that, right, one is favorable, one is not when we first put it together. And what we have two separate compartments. We have the anode and the cathode. The anode is typically written on the left. That is, right, you don't always have to place the anode on the left, like when you physically set it up, but I don't know, kind of a lot of convention has gone into just putting it on the left so that we remember. The cathode is the other component. Each compartment has a solution in it, and each solution has an electrode in it. So in the solution, we'll have, for example, some dissolved ionic compound. So some metal cation with some generic anion. And then the electrode is a piece of metal. I've got generic versions, so right, I've got M prime as my other metal and M prime plus as my other metal cation. Then those electrodes, those pieces of metal, are connected with a wire We usually put a meter in there so that we can measure volts or amps. And then the last piece is this thing called a salt bridge. And what the salt bridge does is it allows ions to move to balance the charges. So the salt bridge has ions in it that move over to the side that needs the appropriate charges balanced. The solutions don't move through the salt bridge. The stuff in the salt bridge doesn't come out of the salt bridge. It's just, it gets on that side of the solution under the level of the liquid so that everything is balanced out. So this is why I get unreasonably excited, is because the two sides don't connect really. I mean, they connect through a wire, but we're not mixing the solutions together. We're not like touching the metals to each other than through the wire, and the reactions still happen because the electrons go through the wire. So obviously we have to have redox reactions, and that will come back to haunt you. Hopefully not haunt you, but we are going to have to deal with redox reactions.